Before we dive in, if this video gets you thinking like a security professional, imagine what a full guide could do. Think like a CISSP teaches you the senior security mindset that separates candidates who pass from experienced engineers who fail. Reason like a security leader, not just a technician. $25 at zerodaylabs.tech. Link in the description. Look at your screen right now. Every login you make, every message you send, every bank transaction you complete, all of that starts as plain readable data. Without protection, anyone intercepting it could read it instantly. Today, we are going to cover two of the most important tools in cybersecurity: encryption and hashing. They both scramble data, but they are not the same thing. And confusing them? That is how security breaches happen. Here is the core question. If both encryption and hashing scramble data, why do we have two different things? The answer is simple. They solve completely different problems. Encryption is designed to be reversed. Hashing is designed to never be reversed. That single difference changes everything about how and when you use each one. Let us start with encryption. You have a message. Let us say, "Hello, Alice." You feed it into an encryption algorithm along with a key. Out comes ciphertext, a completely scrambled, unreadable version of your original message. Now here is the key point. Literally. Because you have the key, you can run this process in reverse. Feed the ciphertext back in with the same key, and you get "Hello, Alice" back. That reversibility is the entire point of encryption. You are locking something up so you can unlock it later. There are two main types. Symmetric encryption uses the same key to lock and unlock. AES is the gold standard here, used in everything from your Wi-Fi to your bank. Asymmetric encryption uses a pair of keys, a public key to encrypt and a private key to decrypt. RSA is the classic example. Your browser uses this every single time it connects to a website. Now, let us talk about hashing. Same input, "Hello, Alice." We run it through a hash function like SHA-256. Out comes a fixed-length string of characters called a hash, or digest. Now watch what happens when we try to go backwards. We cannot. There is no key. There is no reverse function. The hash function permanently destroys the path back to the original data. This is completely intentional. Hashing has two properties that make it incredibly useful. First, it is deterministic. "Hello, Alice" will always produce the exact same hash, every single time. Second, and this is the fascinating part, the avalanche effect. Change just one character. Add an exclamation mark. The output hash is completely wildly different. Not a little different, unrecognizably different. This is what makes hashing so powerful for detecting tampering. If even a single byte of your data changes, the hash changes completely, and you will know immediately. Let us lock in the differences side by side. Encryption is reversible. Hashing is not. Encryption requires a key. Hashing requires no key at all. Both produce consistent outputs for the same input. Encryption is used for secure data transmission. Hashing is used for integrity checking and storing passwords. Both are essential in modern security, but they are tools built for completely different jobs. Where do we actually see these in action? Every time your browser connects to a website using HTTPS, encryption is working. Your browser and the server negotiate a shared key and use AES to encrypt everything flowing between them. Your bank, your email, your messages, all encrypted in transit using TLS. Now for hashing. When you create an account on any modern website, your password is never stored as plain text. It is hashed. When you log in, the site hashes what you typed and compares it to the stored hash. They never need to see your actual password. And this is exactly why Forgot Password does not show you your old password. The site literally cannot look it up. It no longer exists in readable form. Modern systems take this even further with salting, adding a unique random value before hashing to prevent rainbow table attacks. The salt means that even two users with the same password will have completely different stored hashes. Here is the rule. Storing a password, hash it. Never encrypt it. Sending a secret that someone needs to actually read later, encrypt it. Never hash it. The classic mistake is encrypting passwords instead of hashing them. And this mistake has caused some of the biggest data breaches in history. Why? Because encryption requires a key, and if an attacker finds that key, every single password in your database is instantly readable. With hashing, even if an attacker gets the entire database, they still cannot reverse the hashes without enormous effort. Right tool, right job. Every time. Let us recap. Encryption. Scramble and unscramble needs a key. Hashing. Scramble permanently, no key needed. Right tool for the right job. That is what separates a developer who writes secure code from one who creates vulnerabilities. You now know the difference. Now you think like a security professional. Thanks for watching. If this video helped you, hit like, subscribe, and share it with someone studying for their exam. It really does help the channel grow. And if you want to actually pass, not just study, check out 0-Day Labs at www.zerodaylabs.tech. We use adaptive testing that learns exactly where you are weak and drills you on what matters most, so you spend less time grinding and more time progressing. Train, test, certify. See you in the next one.